AI that automatically create test cases for you? Yes, you heard me right. In this episode, we're gonna write a program to analyze screens and automatically create test cases. We're gonna use Chainlit, Langchain, and GPT4Vision to make this possible. And the best of it all, everything will be done in about 200 lines of code. Join with me in this episode and get your hands dirty to build this AI program. So I'm gonna first show you what the application is gonna look like. So this is an application that is built on Chainlit. It will first prompt the user to upload a file. So we'll drop a file into the application. So this is a simple screen I've created in a past project. And you'll see it started to ask GPT-4 for the results. It already starts to create the different test case ID, test description, test data, and expected result. And from here, once the AI is done, we then prompt the user whether they want to upload another or save the result to a file. So let's try to save the result to a file. This then uses Pandas to generate the Excel file, and let's open what the Excel file looks like. So this is what the downloaded Excel file is going to look like. You can already immediately type your test result into the Excel file. That's basically what the application is doing. It receives an input screen and it will automatically generate the test cases. So we'll start off with a clean folder in Visual Studio. So there's nothing in here yet. And the first thing we need to do is to set up our environment. And we're going to use Conda to start with a clean environment. In this case, we're going to issue Conda create. And then the name of the environment is AI Test Planner. And we'll start with Python 3.12. We already have an existing environment. Let's just assume we clean it up again. So now that we have initialized our Conda environment, we're gonna activate it. The advantage of using Conda with a clean environment is that we don't get our libraries mixed up, and we can see that we're able to switch to the environment with this prefix in our command prompt. So we're going to check. So we're going to install the libraries that we're gonna be needing for this application. I already have identified the list of libraries needed. So that's basically the Chainlit, of course, Langchain, and OpenAI. Then we're going to use Pandas to export to the Excel. And again, it's going to take some time for this to install. So now that the installation is finished, let's review first Chainlit. Let's go to the website of Chainlit, and we will see from the installation instruction, it prompts us to install Chainlit, which we already did. And we'll issue Chainlit hello to make sure that Chainlit is properly installed. So we'll just issue here Chainlit hello and see what will appear on the screen. Okay, so we're directed to localhost 8000 and it already started to prompt. So that's just a test installation to make sure that Chainlit is properly working. Once you have Chainlit running, the next step is to look into Langchain integration, because we're going to use Langchain. So there are different integrations here, and inside the Langchain integration you can already see an example code. So we'll just have to copy and paste this and get the application running. So let's copy that now and paste that to our Visual Studio. Of course, the first thing we need to do is to create our Python file. Create new file. We'll call our file AITP for AI Test Planner, and save that file. And then the other thing that we need to do is to create the environment variable and then set the OpenAI secret key. So we'll create another file, call it .env. Your env should have OpenAI key like this, and you'll be able to get your OpenAI key by logging into platforms OpenAI, go to the API portion, and then go to the secret keys, and you can create new keys here. So I already have keys pre-configured, so I'll just copy and paste it. You can do the same with your own key. Be careful with using your own key, because if someone gets a copy of your key, then they will be accessing your API and you'll be paying for all those requests. So you want to keep this secret. So once you have your environment variable configured and the initial integrated application, we can then start Chainlit by running the application, and the command can be found somewhere in the documentation. It says run the application chainlit run. So let's do that in our terminal. Chainlit run aitp.py and then -w. That parameter is to tell Chainlit to continue updating the application whenever code changes. Okay, we can try out if this application is working. Let's just send hello, who are you, and see how this responds. It says here, I'm a knowledgeable historian to provide you with accurate and eloquent answers. And that is because the initial code system prompt that was provided in the example code was that you're a knowledgeable historian who provides accurate and eloquent answers. So we're now able to communicate with OpenAI using Langchain in this with only 38 lines of code. Just a quick walkthrough on the documentation of Chainlit. It's very simple and you can easily understand the different life cycles or events that are supported. There's an on chat start, on message, on stop, on chat end. You can go through this and easily understand what can be supported using Chainlit. But essentially, if you are building a chat interface using AI, then Chainlit is a good place to start. So let's close the other windows first. The advantage of using Chainlit, it also explains what steps has been done in your chains. So let's continue by changing the initial prompt of instead of sending a message is to ask the user for file upload. And in the advanced features in the documentation, we can see that there is an API that we can call so that Chainlit will ask for a user upload. We'll just copy and paste this again to our onStart event so that we will prompt the user for file upload at the very start of the chat. So let's paste it on start, and basically I'm just copying the whole thing and see if we're able to get an upload file. So now, very easy. We already have a function for uploading files. Before we proceed any further, I'd like to explain first what the architecture looks like or the program flow looks like. So we already have different events of Chainlit, and this is what we're going to do. We're going to handle everything on chat start, and then we're going to initialize OpenAI. Then we're going to ask to our upload screen, which we already did. But we're going to create a different method for this one. So we'll just create a method as upload screen to ask the user to upload. Once the uploading is done, we'll then have another method to analyze the image, which calls OpenAI GPT4Vision to analyze the image and create test scripts. Then we'll create a custom output parser so that we can display it properly and ask the user what it will do next after the analysis, whether you upload another document or save the file as an Excel using Pandas dataframe. So there will be 4 methods that we'll be creating, and this diagram basically summarizes the rest of the session. So we're going to extract the ask file message into a method. So we're going to create first a method ask upload screen. Basically, we're just going to copy over the content from the earlier screen, but since I already have a working code, I'll just paste it here and then explain it one by one what it is doing. I'll just delete this on the onStart and put this on a separate method. The things we change is basically we'll have to make this async because the file upload, it has an await method. And then we change the message to please upload the screen layout. I will create the test cases for you, and we will only accept images. And once we have the image, we save it as an image so that we can send it back to the user so that he or she will see what is the image that has been sent. And then we return the path to the message. So this is the ask upload screen, the first method that we are creating. And then we are going to change the initial call on chat start so that we can call this method used by calling ask upload screen and then saving it on a screen path. We also need to initialize our chat OpenAI, and we are going to use GPT4Vision. So we're gonna specifically indicate what model we need to use. So in this case, we'll have to specify the model name. And the model name is GPT-4 GPT-4-Vision Review. Alright, so that sets the model. Now, Chainlit has a session, and we want to save the model into session so that we can use it later. We'll do that by calling cl.user_session set model. So this sets this variable model as a session so that we can call it in other events. So we've initialized OpenAI, and then we have already called the upload screen. So the next set of commands here invokes Langchain to send a message to OpenAI and chain it together and save it to the runnable variable. But we're going to change our implementation in a bit. So we're going to create an analyze image method instead. So this is the method that will perform the analysis on the image. Again, we're going to call it as an async def analyze image. And we specify the path of the image. And I'll copy over the existing code I have, including the prompt, and then I'll just explain how this one is working. Let's start off first with the first part of the analyze image, where we are actually going to first send a message to the user to tell them that please wait, I'll analyze the screen for you. And then we need to translate the image into base64 so that we can pass it over as a string to OpenAI. So to do that, we have a function called encodeImage. It's basically a Python function that converts the image into its base64 format using the base64 library. So let's import the base64, and that's your method for encoding the image. Then we have an image base64, which is a base64 counterpart of the image that we just sent. Okay, let's not worry about the test result output for now. We are not gonna use that. We'll get back to that later. So now that you have your image set up, we want to prepare the prompt that we will send out to ChatGPT, and we use that using chat prompt template. This is the chat prompt template I have. So the chat prompt template includes a system message and the human message, and then it will automatically generate the response. We've already prepared the initial set of prompt. Basically says you're a software tester and you are assigned to analyze screens to create test cases. So usually what you'd want to put in the system prompts are the behaviors or the role that you want the AI to perform. So it says here, then you will only respond to questions related to screen layout. If the image does not look like a screen layout, respond with what you think the image is, and please upload a screen layout. So later on, we can test out if ChatGPT actually respects this system prompt. After the system prompt, then we have our initial prompt that says create test cases for the attached image. Also indicate the file name so that we know what file name are we going to use when we're saving it. At the bottom, it says here at the end of the response in your format. And the file name, and there's an example. So this is an example of a one-shot example that can be used as a pattern by ChatGPT when it sends out the reply. So the magic of sending an image would be in this format. So basically, you have your human sending a message, and part of the message is actually using the type image URL. And instead of sending the actual URL, we're sending the base64 format of the image. And ChatGPT will be able to understand this image and actually process the image accordingly. So once we already have the prompt, we want to send this prompt to OpenAI and render the response in a streaming manner. So this is the code, which is very similar to the code we see earlier. So basically, we invoke the runnable and then send the message, and then we are streaming here. So let's go through the code in here. Let's just replace this with str output parser for now. So basically what we are doing is we get the model from the session, which we saved earlier in the on chat start in here. We save the model here, and then we're retrieving the model, we initialize a message, and then we create a runnable, which is a chain command of prompt, model, and output parser, and we tell it our question to list down all the cases performed this screen. This will then include the prompt, which we have prepared up here, send it to the model, which is GPT4Vision, and then we parse the output. So let's get this running and see how the application works. So we have the file upload, and we are going to upload the file. And in here, you'll see that it starts prompting OpenAI, and it will analyze the screens. And then it started streaming the result. So in this case, it returned the response in a text format and bulleted format in here. So we can actually tell OpenAI to change the format, which is what we call as prompt engineering. So in this case, it is responding in a bulleted format, and we can ask it to change in a text format or a markdown format by simply adding commands in your prompt. So we can simply, this is what the format instructions is here for. So by simply adding instructions in your prompt, you can say that respond in a JSON format, and it will automatically return the response in a JSON format. So let's try that again, and you will see that OpenAI is going to respond not in a sentence format earlier, but instead in a JSON format. So you can already tell what format we want, and based on the test that I've made, it seems like the markdown format is the easiest to read, at least because it's displayed in a table form, and also we want to save it later into a CSV file. Take note, it at the end of the response, it says the file name, and then what is a better file name that can be used, right? So because we included that in our prompt. So if you recall in our prompt earlier, it says here, and indicate a descriptive file name for the test case at the end of your response in the format file name, descriptive file name. So basically, you're telling commands to OpenAI on how the response should behave. So we are now moving on to item number 6 in our outline. We just finished prompt engineering. That's where we use the system prompt, the human prompt, as well as change the instruction to reply in a JSON instead of the usual paragraph. And then we'll move to Longchain Output parsers. Longchain Output parsers are useful because you'll be able to parse the response of any LLMs based on your expected input. So we are going to create our own custom Langchain response, and we'll paste it in our code here in a bit. So I have already prepared a custom Langchain code test output parser. So in this case, I named it test result output parser because it is designed for processing test results of the test cases. And the output parsers of Langchain goes hand in hand with the format instructions and the parse. So they both go together. Basically, in the get format instruction, you will return the instruction on how the response is expected. So in this case, reply in markdown format using the following columns. So I explicitly indicated the columns that I want Langchain to return. And then there's a parse. So in this case, I am not doing anything special with the result. I am just appending them to a variable because I'm going to use later the output when I'm going to save the file into an Excel. So we'll comment out this code first. We'll explain how this works in a bit. But for now, this is what a output parser looks like. It has the format and the parse method. So to invoke the test result parser, we are going to replace our string output parser earlier with this custom parser. So that should be somewhere here. So we're going to use the test result output parser We are going to initialize the test output parser here and save it into the session, as we're gonna use it again later. So we have a test result outer, we have the format response, and we're gonna remove this comment also. Of course, it will be in markdown format, so I'll remove the JSON format. So now the format instruction from the output parser is already being appended to the instructions, and we are also using this output parser to parse the result. So let's try this code change and see what will be the new behavior of the application. So we send the same screenshot, and now we are getting a markdown response. And for markdowns, you'll see this format. They uses the pipe to represent a table, and then you have these lines. So this is the new result with the markdown format. It still returns with the file name, and we are going to parse this markdown so that we can save it into a data frame. So that's what we're going to do in the next piece of code. So if you recall earlier, we are saving the result into self.response. So the entire response string is being saved into the response. So now we would like to have the method save to file, and let's go through this code one by one. So basically, we're using regular expression to look for the triple quote string, because the markdown is enclosed within the triple single quotes, to get all of that. Once we have all of that, we then use string IO so that we can use pandas data frame to read the markdown as CSV, but we are going to tell it to use the pipe as separator. So this will then create a data frame of all the result, which happens to have a column at the start, at the end, that we're not going to use. So we're just removing those columns. We're naming the columns based on the column names that we're expecting, and we look for the file name in the string, and then we replace the file name, and then we call the save to Excel file with the new file name, and there we'll have the file name saved at this location with this file. Of course, let's not forget to include the import there. Include all this import, and now we already have the function of save to Excel. What we need to do is that at the end of the processing of the scripts, we need to prompt the user what to do next, whether they want to upload a new screen or save the file as an Excel file. So we create that method now, and the method, we're gonna call it ask next action. Again, I'm just gonna copy this from an existing code base. So it's ask next action, and then we'll call the ask action message. What do you want to do next? Do you want to upload another or save file? If the user click on upload another, then we'll just call the ask upload screen, analyze the image, and then ask it again. So it's just loops. And if the user decided to save, and then we're going to call the save to file, and then we'll ask the user to click so that they can download the file. So that's the ask next action. So we're going to call the ask next action in the appropriate location, which is essentially, I suppose, at the on start once that's done, and that is after the analyze image is done in this method. So we should be able to handle uploading another image and saving the image to Excel. So let's try that now. In fact, before we do that, let's try uploading a non-screen layout. So let's try to upload something that doesn't make sense. So this is a cartoon. So you'll see that AI respond, the image does not depict a screen layout, but rather an illustration of robots standing on an open book. So ChatGPT is able to understand the instruction that we sent earlier, not to respond if it's not a screen layout. So please upload an image of screen layout for test analysis. Okay, so let's upload another, and let's upload the same screen, or maybe a bit different, but from the same project. This is a tax calendar. It will then again create the test cases, but this time we're going to save the file to Excel. So once the processing is done, you can then click on save to file, which then generates an Excel file that you can download. right? So then you'll see the Excel result in here. Okay, that ends our part for coding. I hope you get a better appreciation of what Chainlit can do in Langchain, and we're able to do the code in about 240 lines of code so far. So we're not handling on message, but basically everything's happened on chat start, and we're just looping over and over again. So let's just do a recap of the program flow. As we mentioned, we have ask upload screen. So at the start, we have on chat start. We initialize OpenAI using GPT4Vision AI. We then have the method ask upload screen, which prompts the user to upload the file. We then have the analyze image, which calls GPT4, and then we have our own custom parser. Then we ask the user what to do next, whether you're going to upload another screen or save as Excel using Pandas dataframe. So there are several key technologies that we're able to play around with in this application. And the last step that we want to perform here is to actually deploy the application to production. So to deploy the application to production, all you need to do is first to set up your Docker configuration, so that when you deploy this to Railway or Vercel, it can automatically create the instance of the image for you. There is already a standard Docker file for Chainlit, and we just need to first create the Docker file in our repository, and we'll paste the content here. So we're starting with Python 3.12. We want to save it in the app folder. We'll install what's on the requirements.txt. We'll build this requirements.txt in a while. And then we call the Python Chainlit AITP, and then we specify the host. So to create the requirements.txt, we are going to issue the command pip freeze requirements.txt. This will create the requirements.txt file with all the libraries that are installed. So this one will automatically install all the libraries I have in my Conda environment. No? So that's why setting up your Conda environment is important, because it goes hand in hand when you are deploying the application to the production environment. So once that's done, you can already deploy this to your GitHub repository and set up your server environment to download the file from your Git repository. In this case, I am using Railway. I'll just quickly go through the GitHub repository. This is my repository, AI Test Planner. I have already uploaded previous project, and we'll go to Railway. So you can sign up on Railway and set up your new project. I already have a previous project already signed up, so I'll just show you the configuration. This is for the same AI Test Planner environment. And essentially what you just need to check out, connect it to your GitHub account and set up your environment variable, the Open API key, and you should be able to get this running. If you got into some trouble, you can always click on view logs, and you'll be able to see the log file so that you can debug. So then you already have the application running. So this is the same application we just created, now deployed on your production environment using Railway. So that ends our session for this Code With Me episode. I hope you're able to learn some technologies and be able to use that on your next project. Thank you for watching another episode of Artificially Intelligent.